Hey, what's up, people? It's Robert Bassano. If any of you haven't noticed, I changed my channel name. Instead of using my first name and first letter of my last name, which is Bassano, I changed it to Planate Veritas. Flat, plain truth. How about that? Latin. So, this is gonna be a short one. I'm going to give you kind of a balance of information here. You guys already know what I believe of the construct of the entire system. I do not believe the entire system is flat. I believe maybe the first three layers are, but the rest of the system is a flattening ellipsoid, okay, which is commonly known or referenced to as a spheroid or an oblique spheroid. So the term sphere, they're too afraid to get away from that, man. They don't want to get away from the term sphere because that's what they've been telling people for fucking 500 years. So they'll put it in the documentation, but they won't go on record to say it's a flattening ellipsoid. But they'll show it in logos. All right. What's interesting? Take a look at the White House plaque in the background when the president or press secretary is speaking, and then compare that to the logo of DARPA. They're identical. It's an ellipsoid. So the White House and DARPA both use ellipsoids for their logos. So my intent, man, for the next maybe couple of weeks, I don't know, man, how long this thing is going to last. Who knows? Who knows? This could break out at any moment, and it's either going to take off, man, at an incredible speed, or it's going to be quashed in a hot second. But in the meantime, I'm going to do my best to drown you all in flat earth evidence. Drown you. I'm going to waterboard the hell out of all of you with just flat earth truth. Planete Veritas. So this document we're looking at here, this FAA, this Federal Aviation Administration, and with NASA, they control the skies as well. So it's a research paper titled, it's a technical memorandum assessing the validity of using actual navigation performance information for supporting designated flight inspection operations. So, what does this have to do with the flat Earth? Well, I'm going to show you. But first, I want to show you this document, what the date of it is, who drafted it, where it came from, who supported it, what the contract ID was. Here you go. All right, you see it here for yourself. Final project report. It goes your table of contents. All right. Very interesting document. I didn't read the whole damn thing, but it's an interesting document. You got some figures here that they show in this document. You got an introduction. Okay? So what we're going to do, I'm going to take you right to the meat. So let's tie you up and let the waterboarding begin. Here we go. Booyah. FAA. Stand by. So here we have our first mention of the flat Earth. Range method. Diagram illustrates simplified method. Simplified method now. I guess the globe ain't simplified. The globe, the basketball, the bowling ball, the nutsack. I don't know. The globe, spheroid, ellipsoid, it ain't simple. It is not a simplified method. They don't have any math for it. They don't have any science for it. They don't know how to calculate it. So, we all see, we all know. We operate, move, function, transport cargo, engage in commerce on a relatively simplified method called the flat Earth. And as you can see here, true aircraft position has ranges whose circles are tangent. Estimate of position depends on measured values, which have error. Measured ranges converted to intersecting arcs as shown. Estimated position is at the intersection of the arcs. Position error, which is unknown, is the result of measurement errors which must be quantified. This is what they're saying. What the diagram illustrates a simplified method, flat earth. So to solve all these problems, you got to stick with the flat earth, baby. You can't continue to believe you live on a spinning ball, man. You're not on a spinning ball. But I'm going to stay true to my claim of what the entire construct is on the outer layers, because there's some rotation out there, people. The first three layers, stationary atmosphere over a non-rotating flat earth. NASA said that. But the outer layers do move. We just don't know how. They're guesstimating. But they don't have any mathematics for it to know precisely. Note that this example shows a second possible estimation of position off the bottom where the arcs intersect again. So here you go. Standard commercial jet aircraft. Estimated aircraft position, right? Constant range arc. True position unknown. True position unknown. I mean, if we got satellites out there guiding these aircraft, how the hell could the true position be unknown? I'm going to tell you why. Because they're still using a dead reckoning navigation system. And for those who don't know what dead reckoning is, it's based on estimated position as you're looking down, as you're referencing on a chart based on triangulation, speed, distance, and time. That's dead reckoning. Speed, distance, and time. And a triangulation of where you think you may be. Okay? We have all these transmitters and towers on the ground whereby, the aircraft can communicate, send a signal down, the signal comes back up to let you know exactly which mile marker you're on, or what geographic area you may be, because it'll send up, its signature to let you know what that tower ID number is. Without that, you're fucking lost in the sky, man. If you're military type, you're basing the shit on terrain association. And if you don't know shit about the terrain, you can't identify what it is you're looking at on the ground. You're fucking flying to nowhere, looking for the nearest airport to land because you're running out of fuel. Okay? So there you go with that. Let's go to the second one. Booyah. True bearing lines to the aircraft intersect at the aircraft true position. Estimated position depends on measured values. We already went through that shit, right? Okay. So it's basically the same thing. They're just showing two aircraft here, right? Trying to make sure that they don't collide or intersect with each other. There you go. That's it, baby. I told you it was going to be short. I told you it was going to be short. There you go. Estimated aircraft position. They had to do all this math. It's based on a flat earth too. True aircraft position. Position relative to VOR depends on measured values, which have errors. Measured range and bearing converted to a relative location, north or east, as shown. Estimated position is derived from combining location of the station with the northeast offset. Position error, which is unknown, is the result of measurement errors which must be quantified to estimate the navigation performance. There you go, people. FAA, Federal Aviation Administration. There you have it, people. There you have it. Need I say any more? You want to question the FAA that why they believe the earth is flat? Go and question them. You want to say something stupid to me, I'll delete that fucking comment. Because I didn't draft this documentation. I'm not forcing them to stick with this model. I told you every single aeronautic, aviation, astronautic company, agency, department, administration, manufacturer, they all use the simplified flat earth method and model. Navigation, you name it. You name it. They don't have anything for the globe. Because it's not a globe. There's a difference between calling it a spheroid and a globe. A globe is a ball. The Earth is not a ball. It's an ellipsoid, an oblique spheroid, with a flat plane surface in the middle. That's it. You don't have to agree with it. You got a complaint? Write to your senator. Send him this video. Tell him to look it up. You need more clarification? Go talk to the FAA. Okay? Next document, please. Thank you. Okie dokie. So I said I was going to be fair and balanced, right? So let me tell you what this document is. Let's be clear on this. Let's tell you what this document. This document, another FAA document, Federal Aviation Administration Flight Inspection Office. Okay? Validation of the Automatic Flight Inspection Instrument Landing System Best Fit Straight Line Application. Ooh, they're talking about flying straight lines, huh? Flying straight lines instead of arcs, huh? Curves around a ball. It shows the difference between A and B is a straight line, right? So let's see where they mention flat Earth. Oh, wouldn't you have it? Oh my God. Alice, you've taken us down another rabbit hole. So again, I'm putting this up as balance. This data, it says right here, was processed using software developed by Ohio University to produce the glide slope error versus distance to threshold results. Figure 1 contains the flow chart for this processing. A review of the AFIS software indicated that this initial processing took into account Earth curvature. Okay, a review that the initial processing took into account Earth curvature. So let's see what the problem was. Further analysis indicated that this error, whoops, you tried to prove the globe, and they looked into it and analyzed it further, and they said, whoa, hold on for a second. But further analysis indicated that this error is minor in computing RDH/ARDH. What's RDH and ARDH? Let's find out. Let's find out. ADRH is achieved reference datum height. Note, the final ARDH is computed by accelerating, yada, yada, yada. Let's see what RDH is. Oh yeah, by the way, AFIS is the Automated Flight Inspection System. They're using some special software. RDH, I'd say that was the reference datum height. Okay? Reference datum height. So we got that clear. People might want to ask, what the hell does that mean? You got to talk to me. Okay. In fact, it says here, at 4 miles, the most sensitive location for the reference data height calculation, at 4 miles, which is the most sensitive location for the RDH calculation, the difference in altitude for Earth curvature versus a flat Earth is 14.10 feet. You saw it, you heard it, you read it. This introduces an error. This introduces an error in the reference datum height calculation of 1.78 feet. In the Ohio University implementation, all values are converted to east-north up coordinates and a locally level plane referenced to the runway threshold. There you go. There you go. You see the problems they have with navigation systems and reference systems with regard to aerodynamics and aeronautics when they try to factor in Earth curvature. When you try to factor in Earth curvature, creating some sort of custom software program to factor that in, look at the problems you have. Look at the fucking problems you have. Just look at the fucking problems you have. Now that may not be much of an error, Okay? 1.78 feet. But it could mean the fucking difference that if you continue down that error path of 1.78 feet, say for another fucking 100 miles, then you end up somewhere you didn't think that you should be going. Your flight plan is all off. You're supposed to be heading to fucking Cleveland, and you end up in fucking Florida, or you end up in the Arctic, because you set up the autopilot. You didn't factor in this math because you're saying, oh well, the Earth is a globe, so let me fly in this direction using dead reckoning, and software will take over. Oh shit, this ain't Cleveland. This ain't Kansas, Dorothy. Click your heels, close your eyes, and say, "There's no place like home." Three times. There's no place like home. There's no place like home, like the flat Earth. So there you have it, people. I don't know what else to tell you. So I didn't mean to take you through 16 minutes of drowning and waterboarding with all this flat Earth data from the FAA, but you get the picture, right? Clean yourself up. Pull yourself together. Prepare yourself for the next session. Who knows when that's going to be. Peace out, people. Remember what I said. What did I say? What's my famous saying?
It's not what you know. It's what you can prove.
Peace out, people.